Seguimos conversando aquí en Científicos Industria Argentina con el doctor Bert Sakmann, uno de los premios Nobel, en realidad lo obtuvo en el año 1991 en medicina y fisiología. I want to ask you, you talked about memory, where the brain, there is a probability that in these spines was left in.
Yes.
What about the learning process? How does our brain learn?
You know, there is a theory that was formulated by a psychologist 60 years ago, or even longer, by the name of Hebb, and he put forward the hypothesis that it is the combined activity of what we call presynaptic and postsynaptic neurons. So neurons are connected to each other. There's a presynaptic neuron that sends information and a postsynaptic neuron that receives information. And they are connected at structures which are called synapses, and the spine is part of the synapse. And he proposed that it is processes are triggered that change the efficiency of the synapse when there is a coincident pre- and postsynaptic electrical event. And researchers still struggle with this, or we take this as a guideline, but the exact molecular mechanisms are still unclear. And as very often in biology, it's probably not one mechanism, but a whole variety of mechanisms. And what you discover in one part of the brain must not necessarily be true in another part of the brain, because it's known that in some synapses you need a very high frequency of the presynaptic neuron. In other synapses, it's sufficient if there is a coincidence activity every now and then, you know. So again, there are two parts. What is the triggering mechanism? And I think the hypothesis of Hebb is still very valid. How it is implemented, so to speak, is probably depend on where in the brain you look. The second question is, what are the molecular processes that are triggered? And again, there is the question, is it a change in the sending neuron or a change in the receiving neuron? Probably the truth is in both.
What are you working on now?
I've been working the last 10 years to reconstruct a small part of what is called the cerebral cortex. So higher brain functions like the one I study, decision making, involve first the recognition of a sensory cue that guides your decision. And if you do this, you first must know how a stimulus is represented in the primary sensory area. And I do this on a rodent model in a asking the question how rodents make decisions when they are asked to jump across a gap, and they do this with their whiskers. So they gauge the distance of the gap with their whiskers and then decide to jump or not. And this is represented in what we call the somatosensory cortex. This is the motivation, but what I did is reconstruct a part of the somatosensory cortex in the greatest detail. So we have now a map of all cells in this part which are registered. We have an idea what are the different cell types, and we have constructed different cell types with respect to dendrites, these are the receiving parts, and axons, these are the sending parts of a cell.
What do you mark those?
Yes, we mark them.
With fluorescent?
Not with fluorescent in the beginning, but with something that is more, gives a better contrast. That's called biosighting. And then we reconstruct them, put them into a Cartesian coordinate system in silico. The whole thing is then in a database. And we have now reached a stage where we can start to look at interaction between different cells in this cortex and try to model what is happening when a whisker is touching an object. So this is I like this a lot because it involves, I'm now almost reaching 70, and the acute electrophysiological experiments are very, very exciting, and you can't leave, you know. Then your wife calls, what do you do in the lab? You know, you're 70. So anatomy is something very, very fascinating. I've rediscovered anatomy. And the final aim is to have a sensory area in silico so that we can ask questions which we can't ask in vivo because they are too difficult. Anyway.
We are getting close to the end,
okay.
But I still have a couple of questions. First off, is there anything that you believe it's true and you cannot prove?
Well, my mentor, Bernhard Katz, who taught me a lot of things, not only scientifically, said if you want to believe, you go to the church.
Okay, well, that's true.
Yes.
No, but maybe you think that in your experiments, you think that something should be happening, and you still didn't have the opportunity to prove it. But you know that given
all the time. I mean, you don't do an experiment without a hypothesis.
No, I know. But maybe you couldn't find the right experiment just to prove your theory.
I mean, the lesson is, if you can't prove it, develop a new method.
Okay.
So you just cut out from your experiments, spend a year developing a new method, and if you're lucky, that's the answer. So this is what I learned. Never stay with the conventional techniques. Not take a break, but stop it and think about a new method.
Do you meet the president?
Yes.
Did it ever happen to you that the president of a country just met you? And
yes. I've been. I've met not the president. Well,
the prime minister.
Prime minister and the president in Germany. I mean, Angela Merkel is also quite interested in science, and she comes almost regularly.
To the Max Planck Institute.
Not to the Max Planck. We have a yearly assembly. I've met the president in Israel. Israel is also very, science-oriented, and I'm very pleased that Argentina does this as well. It's a marvelous sign if the president takes an interest. So
and she does.
She does, yes.
It must be also very interesting to you that in Israel, you being a German, the people in Israel have given you a couple of awards there, didn't they?
Yes, but this is Israel. Israel is a young country, and they don't live so much in the past. They live right now.
Right now.
And this is because I had friends, scientific friends. It just comes natural. You meet somebody, and I was invited to Israel. I like the Israeli type of science, doing it very straight. Anyway, so we had a number of collaborations, and as you may know, I dedicated about 1/3 of the Nobel Prize money for a foundation that gives a prize to young Germans and young Israelis to visit each other's country.
I didn't know.
Because this was, in my case, the first visit in Israel. I thought, what can I say? I shouldn't rather say nothing. But then I was received with such a friendly that I thought, this is the way to go, to expose each other at a very early stage.
Great. I'm going to say goodbye.
Okay.
But before you go, don't leave now. Still, wait a second. Let me say something, because I want to send also a message to the public. I would say, your first language is German, not English. My first language is Spanish, not English. But through English, we got a communication here. So this is also a message, because a lot of people don't know really that when you are told, a lot of kids, you have to learn, you have to study some English or whatever, or another language. It gives you the opportunity to communicate. We wouldn't have been able to do it hadn't you learned a second language and myself too.
Well, if I had known that I'm being interviewed, I would have learned Spanish, you know.
Well, okay, and I could have learned German myself. So we find something in between. Thanks for coming.
Okay,
it was
good.
Great.
It was wonderful. Wonderful to talk to you.
Okay, hold on a second there. I have to say goodbye to the folks. Okay.
Yeah.
Gracias. Nosotros, después de la entrevista con el doctor Bert Sakmann, un gusto tenerlo en el programa, hacemos una pausa y seguimos inmediatamente con Científicos Industria Argentina.
La búsqueda de fósiles es una actividad apasionante, pero debe ser ejercida por quienes se capacitaron para ello. ¿Qué pasaría si encuentro un fósil, lo desentierro y me lo llevo a casa? En realidad, más allá de que es ilegal, desperdicio la oportunidad de que un científico pueda extraer la información que brinda el fósil y que se transmita a los demás. Este enorme dinosaurio se llama Giganotosaurus carolini, en honor a quien lo descubrió, don Rubén Carolini, de Villa El Chocón, en Neuquén. Si Carolini se hubiera llevado estos huesos que descubrió a su casa o para decorar su taller mecánico, nunca nos hubiéramos enterado de que uno de los más grandes dinosaurios carnívoros del mundo vivió en la Argentina. Las ventajas de que los materiales estén en un museo es que no solamente van a estar protegidos, sino que también pueden ser estudiados. Y esos estudios dan resultados que nos convienen a todos. Así que ya sabes, si encontrás material paleontológico o arqueológico, acordate que ese material no es ni tuyo ni mío, nos pertenece a todos.
Cuando volvamos, un proyecto multinacional propone un santuario de ballenas en el Atlántico Sur y llega un nuevo planteo matemático del profesor Paenza.